Welcome back to part 3 of how to simulate, perform, and recover a power off stall. So we've already gone through everything on how to get yourself into the stall, and we were just starting on how to recover from the stall. So once you've experienced the stall, you have the buffet or your nose has fallen below the horizon and you have no more lift, first thing you want to do, keep that nose pitched down, and you want to go full power. So as you go full power, keeping that nose down, you're building your airspeed up. So once you go full power, immediately take out your first notch of flaps. So put a little arrow to show that these are kind of simultaneous. So you do this because you want to decrease the drag. You're trying to get your airspeed back up. That's the whole point of recovering from it, to get lift again and to climb out and get altitude. So after you take out that first notch, you'll take out the second notch once you experience or see that you have a positive rate. So write that and then I'll explain that. So positive rate basically means you have positive increase in airspeed and you're able to establish a climb at that point. So that's what positive rate is, and at that point you want to take out your second notch of flaps. And then last but not least, you want to take out your fourth notch at VY or around 80 knots. So after you've done all those things, by now you should be, out of your second notch, you really should be pitched up to start climbing again. And once you get to VY 80 knots or 80 knots, you will take out your last and final notch and you will climb back up to your altitude that you were originally at. So that's how you recover from it. And the whole point of the recovery is to gain altitude as quickly as possible and to gain as much altitude as you can as quickly as possible. So one thing I forgot to mention over here during putting yourself into the stall and actually doing the stall is you want to stay coordinated. So you do that by using rudder pedals. So you'll notice you have the ball on your PFD there. You don't want that slipping off to one side or the other. So you want to step on the ball, which means you push wherever the ball is going, you push that rudder pedal. So if it's going to the right, you push the right rudder pedal. To the left, you push the left rudder pedal. So that helps you stay coordinated. And the reason you want to use rudder pedals and not your ailerons is because if you use your ailerons too much and too heavily, you can go into a spin, which is a completely different thing. And a spin close to the ground is probably going to be very hard to recover from if it's even possible. So make sure you stay coordinated. We'll write that. And you'll notice if you don't stay coordinated and you are using too much aileron, you will eventually, when you do stall, you'll notice one wing is going to drop low, and that is really the beginning of what would be a spin. So you don't ever want to get yourself in that situation, but that's once again why we practice this at 3,000, 4,000, 5,000 feet, because if you do, then you have plenty of time to recover from the spin, and you have enough time to recover from the stall. So just to go over everything again, so the power off stall, this happens when your critical angle of attack is exceeded or when no more lift is being produced. So that's essentially what's happening, is no more lift is being produced, so you're falling. This is basically practice in the way that you're in the landing phase of flight. So that when you're up altitude practicing this, that is what you're supposed to have in your head, what you're simulating. So we went over how to get into the stall and how to recover it. So it's very important. There's a very I guess methodical way of doing this. So you need to follow all these steps in this order. So pull the power to get into the stall, introduce flaps, like I said, 90, 80, 70 knots. You're gonna do a slight dip, then pitch up about 10 degrees, and that will bleed off the rest of your airspeed to get that stall going. And also